Hello everybody, we have an iPhone 7 which has audio issues, so microphone, speaker, ear speaker isn't working, so we have that common issue with the problem with the audio IC and the flexing board, so that's the reason why it's not working. Let me show you that quick, then we're gonna take it apart and yeah. As you can see here, I can talk, not much is happening. Can turn off the speaker. The main speaker is working, but all of the other speakers and microphones aren't working, so yeah. That's it. I'm gonna take it apart and have a look. Turn it off. Good. The question that I have is normally the audio is grayed out if you're making a phone call. That's kind of the opposite. And we have kind of audio, so let's have a look. I'm gonna open ZXW. Give me a second. iPhone 7. Qualcomm or Intel? Here in Europe we have mostly Intel version. Turn it around to have it the same view. So we are here somewhere on the cap. This F12, it's so long ago since I repaired this. To be F12, which is the issue, which is open line. Interesting, why is that open? Is that the wrong one? Doesn't matter. I'm gonna take the chip out and we have a look at the pads. We are going to look at the pads. Let's fix our microscope so we don't have so much shaking. Good view. Tiny bits and flux. Going 380. 60 air. May cover up the NAND just to protect it a little bit. Only not necessary, but you know what, we could make some measurements around, just to be interesting if we have a different value. So let's do that quick. You can also measure some paths after the chip is off. But let's just try to diagnose that and not just blindly do stuff. So start with resistor here and 4. 4, 6. Third resistor 0.7. That's okay. Take this cap E12. Line, it says open line. Interesting. Cap isn't open. That's definitely weird. Then we have our E12, F12 from C3220, which is the first one here. Point 7. Second one. 0.3. E12 should be open line, but I don't know if maybe we may have different readings when the chip is on. So 0.36. Then not anymore. Chip 3, yeah. Okay, everything seems normal. What else is around here? 0.28, 9, 0.27, 6, maybe because the chip is on, and 6 feels good, and 6, and 6, 3, 6, and 7, open line. We have a lot of open line stuff here around, but we may just get the right values if we take the chip off. So enough. So nothing really strange jumps out at us. So yeah, we're going to take the chip out. Check it right away. Here it is. Put it aside. Cleaning the pads. Good. Good enough. I'm gonna let it cool down a bit. Various stuff. My tweezers are total botched up. Bad condition here, very bad condition. Gotta straighten them up on time. Okay. Doesn't look or seem like we have ripped pads, but let's just check again. Some stuff. Diode mode. 5.4.4.6 open 0.4 round third row 4543 44 420 430 430 430 430 so open See, no connection. Ground. Four two, 4 2, 2 4 2. Good. So let's try D12, E12, F12. E12 is a fourth. 2 6, 2 8. Okay. Open line. Open. 12 is also open line. We have 28. Round. Three, 3, 3, 7, 4 4 7. 2 8 2 7. 0.69, 0.68. 0.4, 0.7. There is a ground pad. 0.7. So do we have a connection to from here to there? Probably. No, no connection. Oh, wrong pin. Wrong side. Ground. So here to seems we found the culprit. So this should be E12, which is 1, 2, 3, 4, 5. Oh, 0 ohms. Oh, of course, we have a connection. My mistake. Zero ohms. Try D12. D12 is normally never an issue. From the resistor here. Oh, it's obviously no issue here, so interesting. Maybe it just has some so-called solder joints. Why should I reconstruct a pad if everything is fine? We didn't rip anything. That common trace, I can't remember. I think it is the E12. Let's look that up. Been a while. Can't even remember. Last audio is, I think, yeah, past a year. Someone pointing out to the right pin. Not really. That's the third pin, which is the common pad which breaks. Not always the same, but the third pin here. Let's test how much resistance we have. 0.1 ohm. 0.1 ohm. My probes tell me 0.2 ohms. So 0.1 ohm is good. One. That's it. So this is not going to be a trace repair. Normally we would make this connection here. I think it's this one. What's the third pin? So look for jumper iPhone 7 jumper. Yeah, it differs. Not always the same. But 1, 2, 3, 4 common pads. I mean, can be a lot of pads. But my pads look are really good, so 1, 2, 3, 4, 5, the sixth one, the cap, we have already measured that. Fifth one is here. Point 2, point 1, then here, point 2, resistor. That'll be the one. No, point 2. Well, no issue. I think when we make a nice reball, that's it. So, no jumper repair. Why should I? All the values are as they should be, so no problem here. So, let's prepare our chip for reball. Some people say, well, that's a common issue. Make a jumper for the future, but the connections are good, so why should I make a jumper? So which Very tiny chip, so not a lot of, well, not a lot of balls. Don't have to be too cautious here. Very dirty, a lot of dirty here. Dirtiness. So we're going to use the chip, put it back on and see if it works. May also be an internal problem with the chip itself. What I use, 183. See, mechanics all passed. Good. Stencil. No stencil for the audio, I see. Okay. iPhone 7. One, but it's dirty. We don't like dirty stencils. Someone didn't clean that. What a shame. I'm going to boil that out with my solder iron. Works good. Tiny bit of schmutz. Good. Put it here in position. Set the temperature, as long as we have two hands. (280), 40 air. Come on. Good. We gotta change hands. Just like this. Warming up the area, surrounding area. The flux is moving. Let's come closer. That. Looks good. First cleaning the stencil, okay. Always keep your stencils clean. Everything is clean here. And add some tiny bits and flux. A little. The chip position. Quick look. We don't have any hairy stuff underneath. Good. Very good. Wow. Oh. Push the hole with the tweezers in my fingers. That's not nice. Cover up the NAND again. Going through 360, 350. Here. So, tiny movement of the chip. Now I gotta add some more flux. I can go to 60 air. Now the chip won't fly off again. And again. Load. Good. That's it. We're gonna let it cool down. We connect the charger because the battery is low. In the meanwhile, nothing. Good. Need a SIM tray and a card. Struggle. I'm struggling to enter a SIM tray. Okay. Good. Let's repeat the phone call. Three. Okay. I'm gonna take on my headset because I want to listen if I have everything here. See that? The speaker isn't white anymore, and I can switch. Yes? Yeah. Test, test. I can hear it. The ear. Hello? 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 That's it. Working. We've done a fix. Good. What was the problem here? I don't know. The phone, as you saw, is really straight. Bad soldering. Normally you have a little bit of flex. You can still have it, even if the phone is straight. That's not the first time. That behavior. We're gonna take the board out again. We're gonna add some on that line in between. We're gonna add some glue, epoxy. So let's begin. Just gonna fill up that gap. That's all. Cup is filled. My fingers are full of epoxy. Love it. Good. Now we're going to put that shield back. Just like that. Good. Not like new, but good enough. 12-volt line, E12, F12, D12. I'm not sure about. They can all fail. Also this one here, E12 is common. Then these here, these three resistors here. No, this one not. This one here, no, also not. Where is it? This one. So these two down here, this one, F12, E12, and yeah, D12, G12 are together. So yeah, but that's not very common. Really common are really C12, I think, E12, F12, and J12 and H12. What I have shown until now. But yeah, that's it. Thank you for watching. I hope you enjoyed it. And if you want to support me, give me a thumbs up. It will help me with the channel a little bit more, and yeah, to make more good, interesting content. And I hope you're gonna see you again. Thank you for watching. Goodbye.